Hello, welcome to our REDSHORT for this Wednesday, July 1st. My name is Nathan Burnham, and today I will be discussing a recent malicious crypto clipper USB worm. As always, you can find information on similar topics at redskyalliance.org. This USB crypto clipper is a Trojan deployed via USB storage devices that has been affecting users since February 2026. It looks for clipboard data and other valuable assets predominantly associated with crypto wallet addresses and exfiltrates this information with Clipper malware. It does this through a bundled Tor proxy using Windows, script host, and ActiveX logic to connect to a hidden C2 server carrying out high-frequency clipboard theft, collecting screenshots, and running crypto wallet address substitutions. Unlike most malware, this does not depend on an installer or exposed IP-based C2 infrastructure. It deploys a portable Tor client, routes traffic through a SOC 5 proxy, and mixes data exfiltration with remote code execution. This particular malware is made of two components: a worm to ensure propagation and a clipper component to steal valuable information. The worm works by creating additional malicious shortcut links of legitimate files found on the device. It delivers file-based payloads and excludes them from Windows Defender scanning. In addition, the worm component deploys scheduled tasks for execution and persistence for both components. The clipper runs script-based payloads to interact with the operating system through WScript and the ActiveX object. It runs anti-analysis checks that look for running processes and exits if Task Manager is detected. Otherwise, the clipper launches a Tor binary, ugate.exe, waits for Tor to bootstrap, generates a victim GUID, and registers the infected device with the hidden service C2 server. The initial access for this malware occurs from malicious.link files distributed from USB storage devices, according to the Microsoft Defender Security Research Team. This .link payload will search for common document files such as .doc or .pdf, hide these files, and replace them with the link files of the same name. When clicked, these shortcut files fetch the worm payload from the C2 server through Tor, without alerting the end user. As the worm payload runs, it excludes staging folders and Windows binaries used in the stealer component execution to avoid detection. The malware will then drop decrypted payloads, including two malicious JavaScript files and the user's public documents folder. Additionally, this worm component will create two scheduled tasks: one to insert itself into any uncompromised USB storage disk inserted in the future, and another for the clipper activity. When the clipper is active, it connects to the C2 server over the Tor routed domain through the local port on port 9050. This helps obscure the final C2 destination and complicates destination-based blocking. It also helps keep anonymity for the malicious actor while keeping the malware compact. The C2 has three endpoints: route.php for beacon and command retrieval, receive.php for file uploads, stub.php for the initial payload download. The C2 can receive different actions from the malware: receiving information concerning the victim GUID, stolen seed phrases, stolen private keys, and notice of address replacement. Lastly, the C2 can deliver the command GUID or eval. The GUID command will acknowledge receipt of the victim GUID or request a refresh. The eval command will allow for the remote execution of additional JavaScript code. The clipper focuses on high-value financial assets. It detects all 12 or 24-word BIP39 phrases in the clipboard data. It will save these seeds to a local file as a backup and send it to the C2 domain via Tor. It retries until the receipt is acknowledged, then deletes the local backup. I'll also take 5 screenshots and upload those as well, giving the threat actor additional context on the victim's wallets and balances. Other functionality the Crypto Clipper has is to detect cryptocurrency addresses, replacing them with attacker-controlled addresses, so any copy and paste cryptocurrency payments will be received by the attacker rather than the intended recipient. To detect this malware, you may need to look for any script interpreters spawning suspicious child processes, monitor your device for any localhost 9050 proxy usage, identify screen capture commands running in PowerShell, monitor for signs of clipboard inspection, or watch for any instances of crypto wallet address replacement. To protect against this malware, disable auto-run or autoplay options for removable media. Block link execution from removable drives. Restrict unnecessary use of WScript, CScript, similar. Investigate script and network chains involving curl, PowerShell, or cmd.exe, and monitor for any SOC 5 proxy activity. And lastly, review any clipboard and screen capture behaviors. That's it for us today, and thank you for joining. I hope you enjoyed the material and found it useful. If you have any further questions on the subject, you can contact us through Jim McKee at jmckee@redskyalliance.com. Have a nice day, and we hope to see you again next week.